Okay, Assalamualaikum and a very good evening. Today we will do a video presentation about experiment 1, which is flow measurement, which is involving water. So we will start with introducing ourselves. So my name is Muhammad Alif Iqmal bin Zulkafli. My matrix number 198978.
My name is Farhani Sufia binti Warusman. My metric number is 197554.
Hi, my name is Nur Farhani Intan Suraya binti Salman and my metric number is 196X40.
Okay, so I will begin with the introduction. Right, in most of nowadays industrial process, it is really significant to measure the rate of fluid within the system precisely. Hence, to measure the flow rate of any fluid, a device called flow meter is widely used in the industry. So, what is flow meter? Flow meter is instrument that measure the amount of liquid, gas, or vapor that pass through it. The flow meter consists of three parts, which is primary device, transducer, and transmitter. It works by the fluid that passes through the primary device is sensed by the transducer, and then the transmitter produces an important flow signal from raw transducer signal. However, an actual flow meter may have one or more of these physical devices. There are many types of flow meter, for example, Coriolis flow meter, ultrasonic flow meter, venturi flow meter, and so on. In many of applications, choosing the best flow meter is essential because the accuracy of measurement depends heavily on this factor. So we move to the theoretical or fundamental background. So in this experiment, the equipment used was installed in a series configuration to permit direct comparison. A flow control valve permits variation of the flow rate through the circuit. Pressure tappings are incorporated so that the head loss characteristic of each flow meter may be measured. These tappings are connected to a tube manometer bank, incorporating manifold with an air bleed valve. So in this experiment, 4 different types of flow meter is used, which include venturi flow meter, orifice split meter, rotameter, and bench device. The bench is used as the source of water supply and for volumetrically calibrating each flow meter. The liquid involved in this experiment is only water. So this is the basic bench and flow meter demonstration apparatus, model FF101. This is the rotameter, the orifice split meter, a venturi flow meter, and also the bench device. So this experiment relates well with the equipment which is venturi flow meter and orifice split meter with Bernoulli's effect, which is say that when the fluid speed increase, the internal pressure will decrease.
Next, we move to the objective of this experiment. First, to compare fluid volumetric flow rate measurement between venturi, orifice, rotameter, and bench device. Second, to compare head loss between venturi and orifice. Next, we have the detailed operating procedure. This is the figure of the flow rate apparatus. We have flow control valve, outlet pipe, inlet pipe, venturi meter, orifice split, bank manometer, rotameter, air blend screw. Now let's look to the function of each object. First, venturi meter are flow measurement instruments which use a converging section of pipe to give an increase in the velocity and a corresponding pressure drop from which the flow rate can reduce. Second, orifice split. Orifice split is a device used for measuring flow rate, for reducing pressure, or for restricting flow. In the latter two cases, it is often called a restriction plate. Next, rotameter. Rotameter is a device that measures the volumetric flow rate of fluid in a closed tube. It belongs to a class of meters called variable area meters, which measure flow rate by allowing the cross-sectional area the fluid travels through to vary, causing a measurable effect. Then, flow control valve. Flow control valve is to regulate the flow rate in a specific portion of hydraulic circuit. And next, air bleed screw is a device used to create a temporary opening in an otherwise closed hydraulic system, which facilitates the removal of air and another substance from the system by way of pressure and density differences. Now let's look to the experiment. First, we have to set a flow rate as 5.0 liter per minute measured by the rotameter. And then you have to close the drain hole with the rod provided and obtain the collected water volume in some tank for 1 minute by closing stopwatch once the drain hole is fully closed. Third, once completed, open the drain hole to avoid spillage. Fourth, at the same flow rate, you have to record the manometer reading to obtain the pressure difference in the venturi tube. And also you have to record the manometer reading to obtain the pressure difference in the orifice tube. And lastly, you have to repeat the procedure for 10, 15 and 20 liter per minute of flow rates measured by the flow meter.
Okay, I will start with the data collection table, which is table 1. We can see that this is rotameter flow rate that we set, the best device that we get, and this is the reading. So the table 2, which is head loss, we divide it into venturi flow meter and the orifice meter. So for the table 3, which is water flow rate, we have to get the reading for the water flow rate, and the table 4, which is percentage error, we need to calculate each of the rotameter. So for the discussion, from data obtained from the experiment, we can compare and contrast the different types of flow meters that are available on the market. So for the bench device, at the beginning of the experiment, a flow rate of 20 liter per minute is set, followed by 15 liter per minute, 10 liter per minute, and lastly 5 liter per minute. So based on the experiments, percentage error on batch device shows that 5 liter per minute flow rate is the lowest, followed by the 20 liter per minute, 15 liter per minute, and the highest is 10 liter per minute. Maybe this accuracy can be caused by the errors present in conducting the experiment. So the venturi meter, for the venturi meter, a different trend is observed. The percentage error is lowest for the flow rate of 15 liter per minute, followed by 10 liter per minute, 15 liter per minute, and lastly 5 liter per minute. For 20 liter per minute, the percentage error is 20.78. For the 15, we get the smallest percentage error in this experiment, which is 15.6. For the 10, percentage error is 20.42, followed by 39.88 for 5 liter per minute. So for the orifice meter, we can observe a trend in these readings. A flow rate of 20 liter per minute is set, followed by 15, 10, and 5. So a trend is observed. The percentage error is lower at flow rate of 5 liter per minute, which is 17.59%, followed by the 28 liter per minute, which is 19.78%, then 50 liter per minute, which is 22.6%, and the biggest percentage error goes to 10 liter per minute, which is 23.35. So for the conclusion, in conclusion, all of these equipment are used to measure the pressure drop over an obstruction inserted in the flow, and the pressure flow meter is based on the Bernoulli equation. So next, the head losses of venturi flow meter is higher than orifice meter because of the large drop in the pressure due to the friction inside the venturi flow meter. So for the lastly, venturi meter is the most accurate device because of the streamlined design, its radial contraction and expansion purely flow separation, and swelling, and it suffers only frictional losses on the inner wall surface. So that's all from us. Thank you.